Hello, this is Dr. Wright. So today what I want to try to demonstrate to you is how you can use a bond portfolio and the individual durations of the bonds in the portfolio, and then use strategic weighting with those bonds in order to effectively hedge the interest rate risk that you face on the liability side of your ledger. So let me try to give you an example here. Suppose that you're a large commercial bank and you issue a large certificate of deposit, and the amount of the certificate of deposit is $100,000. So you've just put out a $100,000 CD. You've offered a rate of 1.5%, and we're going to assume that's just an annually compounded rate of return. So that's both your APR and it's also your effective rate. So your coupon rate and your yield to maturity when you issue the CD are both 1.5%. I'm going to assume it's a 10-year CD, so if we have a settlement date of October 2nd, 2012, we're going to assume that this liability for us as a bank is going to come due on October 2nd of 2022. And again, like I said, we're going to assume that this just makes interest payments once a year and it just compounds once a year. So I'm using the bond pricing and duration calculator that I've shown you in previous demonstrations to just figure out some of the attributes of this liability. Now, obviously, since the coupon rate is matching the yield to maturity, which is fairly common when you issue a CD, more than likely the coupon rate that you attach to it, or the market, or I should say the rate that you actually offer your depositors, is going to be pretty closely aligned with what the prevailing average yields are out there on certificates of deposit. So since your coupon rate matches the yield to maturity, then the value of your liability is going to be $100,000. We're not really having to worry about clean versus dirty prices because we're issuing this on the settlement date. So we have a value of our liability is $100,000. Now if you look down here, you can see that this does have a duration of 9.361. We can figure out the modified duration. Remember, modified duration is your Macaulay's duration divided by 1 plus your periodic rate. Since this is an annually compounding instrument, all you have to do is take your Macaulay's duration and divide it by 1 plus your yield to maturity. That gives you your modified duration. Well, you can multiply your modified duration by minus whatever your expected change in yield to maturity is to get an approximation of how the value of this asset or liability will change with changes in the yield to maturity. So, for example, if we thought that the market yield to maturity on certificates of deposit of this type was going to decrease by 0.25% or 25 basis points, then our duration approximation suggests that the value of our liability will go up by about 2.31%. So if the yield dropped from 1.5 to 1.25, you would see the price go up by about 2.31%. And you can see it goes up by a little bit more than that. Obviously, our convection approximation is much closer than our duration approximation, but the duration approximation works for us. Main point being, if market yields drop, the value of our liability goes up. Now, it's not necessarily that our bank is having to pay more money to our depositor. We're still paying the same interest rate, and we're still going to pay them the $100,000 at maturity. What's happening, however, is that on a relative basis, we're starting to lose here. We've locked in an agreement where we're paying someone 1.5%, but now the prevailing yields out there are only 1.25%. Well, as a bank, we'd much rather be paying 1.25% than 1.5%, and it turns out that the depositor who owns this CD now has a valuable CD. He or she has a CD that's paying above market rates because we're paying 1.5% and the market's only offering 1.25%. There is a secondary market for CDs, and so they could go out and sell their CD on the secondary market for $102,336.38. So you can see the value of the liability is increasing. Well, as a bank, it's in our best interest to try to immunize this liability. In other words, to try to create a portfolio that can hedge our liability so that if the value of our liability goes up, the value of our portfolio of assets also goes up. In order to do this, and I'm just trying to demonstrate for you here, trying to give you a quick demonstration, all I'm going to do is I'm going to throw together a portfolio of 5 bonds. I'm not going to be terribly picky about what bonds they are. We're just going to go grab some treasuries, maybe a couple of corporate bonds, and then I'm just going to try to show you how you can use the solver function to get the right weights to match the duration of your bond portfolio to the duration of your liability. And you'll see that if you can do that, you will have a pretty effective hedge against interest rate movements. So I'm going to shift you over to this spreadsheet. Okay, so the total value of the liability that we want to hedge is just this original value of the liability, the $100,000 that we started out with. The duration of the liability, we can also just link up right here. There's our Macaulay's duration. So what we want to do is we want to try to put together a bond portfolio, get the appropriate weighting in that portfolio so that we can match the duration of this liability, and that will help us to hedge our interest rate risk. So let's just go grab 5 different bonds, and we'll make the majority of our portfolio treasuries. So I'm just going to go to FINRA, I'm going to go to investors, I'm going to go to bonds down here in the market data, and I'm going to go to the advanced bond search. And all I'm going to do is I'm just going to look for U.S. government notes, and we're just going to look for maturities that are basically between 20 and 30 years, or I should say 10 and 30 years. And so I'm just going to see what this pulls up. It should pull up quite a few treasury bonds for us, and I'm not going to be picky, so I'm just going to grab the first one here. So it has a maturity date of 11/15/22. It's got a coupon rate of 7.63%. It's got a yield of 1.73%. They pay out semi-annually. So let's just go grab some bonds, and then we'll work with the formulas here. Let's grab one that's a little bit longer term. So, in fact, why don't we grab 2 that are a little bit longer term? So like right here. This one expires in 2032, so 4/15/2032. 2032. Coupon rate of 3.38 and a yield of 0.0245. And that's also going to pay semi-annually. And then let's go grab a little bit shorter term one, maybe somewhere in the middle between those. So I'm going to grab... let's just grab this one right here. So 11/15/2026. It's got a coupon rate of 6.5. Okay, and there's our bond, and it has a yield of 2.242. And again, semi-annual coupon payments. And why don't we go grab a couple of corporate bonds now? So let's go back to our screener. And all I'm going to do is, Hershey's I know has lots of bonds, and they're a relatively stable company. And why don't we just grab one of these? So this Hershey's bond right here has a maturity date of 12/1/20. And it's got a coupon rate of 4.13. And it's got a yield to maturity of 2.302, semi-annual payments. And why don't we go and grab one more? So let's go grab a Nike bond as well as a Hershey's bond, get into a different industry. And so we can see that Nike has a bond that's expiring 10/15/2015. And it has a coupon rate of 5.15 and a yield to maturity of 1.37. And so let's assume that we're going to buy these bonds at the same time that we actually issue our certificate of deposit. So we have a settlement date of October 2nd. And we'll just copy that down the line. Okay, so we're just going to go ahead and use the price function. We demonstrated previously that we can trust this function to give us the right price. So we're going to give it a settlement date. We're going to give it a maturity date, a coupon rate, a yield to maturity. It needs to know a redemption amount. We'll just put $100 in for our redemption amount. And the frequency is it's going to be semi-annual, so that means there will be 2 payments per year. We'll hit that, and it will give us the price of the bond. Slide that formula all the way down, and now let's figure out the duration. Same thing, settlement, maturity, coupon rate, yield to maturity, frequency, and those are the durations of our 5 bonds. Now remember, the whole idea of what we're trying to accomplish here is we want to immunize our liability. When we say immunize, we mean hedge against interest rate risk. So, right, if interest rates drop in the CD market, the value of that liability is going to go up, then we would like to see the value of our portfolio of bonds go up by the exact same amount to precisely offset the increase in our liability. Well, the nice thing is that portfolio duration is just the weighted average of the individual durations. Now, if we did an equally weighted portfolio, so if we just did 20% in each of those bonds, then I'm just going to use the sum product function here. So sum product will take this column and multiply it against that column and then add it up. Handy little function. You can see that we get portfolio duration of 8.481%. I'm going to need this here in just a second, so I'm going to make sure that our portfolio weights sum to 100%. We want to make sure that we have 100% allocation in our portfolio. So what I want to do is I want to use the solver function to get a 9.36 duration, which will then effectively immunize our liability. So let's do that. Let's go to Data, Solver, and what we want to do is we want to set this, our portfolio duration, exactly equal to 9.36 as we see right here. Now you may want to, and I do recommend this, you may want to carry that out a couple decimal places. So 9.3605. So now we go to our solver function and we'll get a little bit more precise here. So we want to set that equal to 9.3605 by changing our weights. And what constraints do we want to put on it? Well, you can see I've already entered the constraints here, but let's go and look at them. So the first constraint that we've entered is that J15, which is our total portfolio weight, has to equal 1. So we have to have full allocation within our bond portfolio. The second constraint is that we can't have negative weights. It's very, very hard to short bonds, and so we want to keep all of our weights in the portfolio greater than 0. So if we do that, we should be able to hit the solve button. Let it do its magic, and you can see it spits it out, and so these are the appropriate weights for us to try to achieve in our bond portfolio. So what does that mean we're going to do? Well, look, the total value of our portfolio needs to match the initial $100,000 liability. So what we're going to do is we're going to take the initial value of our liability and we're going to multiply it by our portfolio weights, and we need to lock in that B so that it doesn't shift. I've shown you that in previous demonstrations, so we lock that in, slide it on down. Add that up and it should add up to $100,000. Okay, so what you would do is you would invest $15,723.82 into this first treasury bond, $27,719 into the second treasury, on down the line, so you'd have $19,000 in the Hershey's bond, $14,000 in the Nike bond. Now you could actually figure out how much par value you're actually buying when you make these investments. Notice that almost all of these bonds are trading at very heavy premiums. That's because their coupon rates are well in excess of the yield to maturity. So to figure out the par value, it's actually a pretty easy calculation. All you have to do is first off determine these prices in a percentage term. So instead of a price of 154, we want to think of that in terms of percentage of par value. So that's actually 154% of par value. And all you would do is divide your investment by the percentage, and that would tell you the par value. So I would just take the investment and divide it by the percentage of par value. In order to get percentage of par value, just take your price and divide it by 100. So that simple formula, investment divided by percentage of par value, will tell you how much par value you're actually getting. Whoops, didn't mean to slide it all the way down. So that's how much actual par value we're getting. Now what I want to try to show you is this. You've created a portfolio that has a duration of 9.361%. It should be almost precisely identical to your liability. What we're going to do is we're going to allow the yield to maturity to slide on us, and I want to show you that the value of your assets is going to increase by almost exactly the amount by which your liability increases. Now what I want to do down here is I want to create the exact same portfolio, so I'm going to copy pretty much everything from up above. So I'm just going to copy that, and I'm going to copy that, do the same thing there and do that. And I need to turn that into just a general number. Don't freak out when that kind of stuff happens. It's just a formatting issue. All right, and then just want to use the price function again down here like we did previously. So price, settlement date, maturity date, coupon rate, redemption amount, 2. So just using the price function again, and again using the duration function. So just working through a lot of what we did up there. Okay, and for the weights, I just want to make it exactly equal to up there. And then I'm pretty sure I can just copy and paste all these formulas down. I probably could have copied and pasted those other formulas as well. So, okay, at this point I should be able to just drop and drag and we're good to go. Okay, now the only change I want to make is we're going to allow the yield to maturity to float on us. So I'm going to make my yield to maturity down here equal to my previous yield to maturity plus whatever change we're going to allow to take place, and I'm going to lock that in. Okay. So here's what we're going to do. We're going to shift the yield to maturity on both our liability and on our bond. So first off, let's go shift the yield to maturity on our liability. We're going to drop it, okay, to 1.25. You can see our liability goes up. I'm going to go ahead and grab that and put it right here, our total liability from the previous tab. So there it is. Okay. I'm just, again, right here figuring out the duration of my portfolio. Nothing exciting going on. And again, just summing this up. Okay. Okay, so now we're going to drop the yield to maturity in the bond market by 25 basis points. So there is my 25 basis point drop. You can see that all my yields to maturity down here are now 25 basis points lower than they were previously. We're going to add up the value of this bond portfolio, which has changed. The prices have changed. And you can see our liability went up to $102,336.38, but the value of our bond portfolio also went up to $102,336.38. So you can see that there is literally almost no variance. The value of our assets moved by the exact same amount that the value of our liability did, and there's really no need to even do this percentage variability, but you could just take that variance and divide it by your liability for a percentage variance. So you can see you have effectively hedged this liability, and it doesn't matter what direction the yields go. So for instance, what if the yield goes up on the liability? So now what if prevailing CD rates are 1.75%? Well, your liability has gone down, which is nice, but that also means that the value of your portfolio of assets has gone down, and you can see that the change is almost exactly equal. Now, the one little caveat that I need to give you on this is please notice when we first formed the portfolio, we perfectly matched the portfolio duration. The duration of the liability was 9.3605. We perfectly matched our weights to get a 9.3605 duration in our portfolio of bonds. However, once the yields change, now our durations are off. So look, the yield has gone up by 0.25%, 25 basis points. Now our portfolio of bonds has a duration of 9.311, but the duration of our liability is 9.351. So just notice that once yields change, now your durations are off, and that's going to necessitate some rebalancing. And like you learned in the book and in lecture, really the only way to get out from under that is if you just do zero coupon bonds. So if you do a zero coupon bond that gives you a perfect duration match, then you shouldn't need to rebalance when you do that. I just realized there's one other little caveat that I should give you. Please make sure that when you do something like this, that your yield to maturity in your asset portfolio is exceeding your yield to maturity in your liabilities. I can tell you that it is, and I'm not going to walk you through the somewhat involved steps to make sure that that's taking place. But you can see that your yield to maturity over here is 1.7. Well, it started out at 1.5% if we put it back. So when you initially gave this CD to your depositor, you had a yield on your liability of 1.5%. Well, if you look at the yields on your bonds, they're almost all in excess of that. The only one that's not in excess of that is your Nike bond at 1.37, but you're only putting 15% of your portfolio there. So I can guarantee you that the yield on your assets exceeds the yields on your liability. Well, look, this is how you make money, right? You borrow at 1.5%, and then you invest it to earn 2.3, 2.2, 2.45, 1.7. This is precisely how you make money, and by matching those durations, you've effectively hedged at least the interest rate risk on your liability. So I hope you found the tutorial helpful. I hope it's been informative. I hope that it's also helped to clarify the content of what we're studying, and I hope you feel like you could easily recreate it. If you have questions, feel free to contact me or the teaching assistants.